Okay, so yesterday we talked about heat capacity of a calorimeter. Remember that heat capacity is different than specific heat. In our equation here, we have Q reaction equals the negative of heat capacity times change in temperature. I told you yesterday to make sure you identify that as a capital C, not a lowercase c. And how do you know when to use which equation? Because we'll have the two equations. We'll have the, as we look at this, we're going to have two equations. We're going to have, maybe, Q equals negative M times C times delta T for reaction. And then we'll have Q equals negative C times delta T. Okay, so how do you know which one to use? Well, they're going to tell you heat capacity here. So they'll tell you heat capacity here. And they'll tell you specific heat here. So you know to use the top formula when they say or ask about specific heat. You know to use the bottom formula when they say or talk about heat capacity. Questions about that? All right, you can label these on your blue cards if you want. Okay, so that's just a picture of the bottom calorimeter, and this is problem number 11. Okay, so I get through this problem and I see something that helps me. I see the word heat capacity. Another hint, heat capacity, would be bottom calorimeter. If they refer to either of those phrases, you know to use the Q equals Q reaction equals C times delta T, and that's a capital C. Now, these set of problems are often tricky because what is A asking for? It's asking for Q for the calorimeter, right? Mm-hmm. Okay, well, Q for the calorimeter is opposite in sign for Q reaction. So Q calorimeter would be C times delta T. Okay, now that's not on your blue card, but we do know from your blue card that Q reaction is equal to the negative Q calorimeter. So if you know the sign of 1, you know the opposite sign would be true. If one's positive, then the other one's negative. If my reaction is positive, then my calorimeter would come out negative. If my calorimeter is positive, my reaction would be negative. So it's asking us to solve for calorimeter, so we're going to do that. And notice I do no longer have a negative symbol in there. So we're going to put in our heat capacity, 10.34 kilojoules per degree Celsius times my delta T. So now we got to figure out what our delta T is. And what is our delta T? How do I do delta T? Always final minus initial. So 39.7 degrees Celsius minus 23.5 degrees Celsius. All right, so let me grab a calculator. So we get 10.34 times parentheses 39.7 minus 23.5, close my parentheses, and I get, let's see, how many sig figs can we have? We can have 3 sig figs, so 168 kilojoules. Now, why is it kilojoules and not, what happened to my degrees Celsius? Yes, they cancel. I have degrees Celsius here. That's going to cancel with these because they're going to be added or subtracted. However you look at that. All right, questions about that piece? What the problem is and what makes this tricky is it asks about the calorimeter first, and then down here it's going to ask about the reaction. So you want to really think about the fact that, really the calorimeter is the opposite sign of the reaction. Okay. B, what is Q when 5 milliliters of ethyl ether is burned? Well, that's what this, if you read this, which I didn't read it out loud to you, it tells me that 5 milliliters of ethyl ether is what produces this temperature change between 23.5 up to 39.7. So if I know that 5 milliliters produces that temperature change. So then I know that this is just Q reaction. So it's going to be negative 167 kilojoules. And that's because Q calorimeter is opposite sign to Q reaction. So that's kind of what you say there, just to make it clear to the person or to the grader, which will be me, that you understand why I'm just changing the sign. Oops, I'm sorry, this should be an 8. I was, yeah. doesn't change by 1 kilojoule. I just was being sloppy. Questions about that piece? This is not going to be a situation where question B is going to be different from what's up here. Okay? Whatever's up here, that's what they're asking for in B. Okay? Whatever produces that change is what they're describing. But part C does do a little bit of change here. So let's look at part C. Part C is very similar to what we did yesterday, where we now have a relationship that we've established. That relationship that we've established is between the kilojoules and what? Well, we know when it reacts, it has negative 168 kilojoules, right? So that reaction produced a negative 168 kilojoules when I use 5 milliliters of ethyl ether. So that's my relationship, 5 milliliters and negative 168 kilojoules. I got to pick the reaction value, not my calorimeter value. Okay? So then I'm going to start with 1 mole of ethyl ether. I believe I gave you the formula for it, C4H10O. How do I get rid of moles of something? We talked a little bit yesterday. I could use the mole-mole shuffle. But remember, when we do moles to moles, that's trying to get us from one part of a reaction to another. And it's not asking about anything but ethyl ether. So I would not want a mole-mole shuffle, but I would want to use the periodic table value for this. So we're going to figure out what the molar mass is of ethyl ether. I have it written down somewhere in my notes, so I'll grab it, unless someone already calculated it. 74.14 grams. So 1 mole goes down here. Let me erase this just a little bit. 1 mole of ethyl ether equals 74.10 grams of ethyl ether. Now, where did I get that? I used the periodic table. 4 hydrogens, or 4 carbons, 10 hydrogens, and an oxygen. All right, so now moles cancel, and I have grams. Well, what's our relationship? I'm going to go back up. What is our relationship? Our relationship is between 5 milliliters and negative 168 kilojoules, isn't it? But I'm in grams. What is my tool that I can use to get me between grams and volume? Density. Good job. Density. We know the density, it's kind of shortcut there, it's 0.714 grams per milliliter. Keep in mind, and I've talked about this from the beginning of the semester, the 0.714 stays with the G, because it's the unit on top, and that's going to be over 1 milliliter. Okay, so we've got to think about what that is. So then, I know I need 0.714 grams of ethyl ether for every 1 milliliter of ethyl ether. Now, why did I put grams down there? Because I had to, so my units cancel. Keeping in mind your density value, the G stays with the number, and then it's over 1 milliliter, or set up as a ratio with 1 milliliter. Now I have milliliters, but that's our relationship. Our relationship is between 5 milliliters, 5.00 milliliters of ethyl ether equals negative 168 kilojoules of ethyl ether. We just established that with our heat capacity calculation. So now milliliters cancel, and we have kilojoules. So if you go through all that math, I get a negative 3.49, negative 3.49 times 10 to the third kilojoules of ethyl ether. Now, what does the negative tell me? This was your bell ringer question. What does a negative Q tell me? It tells me that heat is released, right? Or it's exothermic. Heat is released or it's exothermic. Questions about C? A, B, or C? Yes?
So, on D, is it just, the actual reaction, do you just take the opposite of the calorimeter?
Yes. Because what I want here, what it's asking me in 4A is of the calorimeter, but the only formula we really have is for a reaction. But we know that the reaction is opposite to calorimeter. So then I can just make my Q calorimeter to be this, do my math up here, And then what I really know is that part B was actually for the reaction. I just get to change the sign. So part A, and these I wish they would reverse these in the textbooks, but they don't. So I want to show you how they do it in the textbooks. Part A and part B are sort of done at the same time. You figure out A by using C times delta T without the negative symbol, because then you're solving for the calorimeter. And then you reverse that sign in B is all you do. You just reverse the sign in B. Okay?